So here, if we draw the diagrams of linear impulse and momentum, this can help us into doing the solution, because at initial state, what is the initial linear momentum? It's decomposed into x and y. So for particle A, I draw MAVA x1, MAVA y1. And we know that the impulsive force here is along the line of impact. And since we have smooth spheres, there is no friction, so no impulsive force in y. And since there is no impulsive force in y, so y velocity will remain the same. So if you apply the principle of linear impulse and momentum in y direction, you say MAVAY1 plus integral Fy dt, which is 0, equals to MAVAY at state 2. So that's why we can say directly that because no impulses along y, velocity in y will remain the same. So VAY1 equals to VAY2. While if we apply the principle of impulse and momentum in x, if we take A alone, then we'll have two unknowns, the impulse and VAX2. This is why we take system A plus B, because when we take system A plus B, the impulses will cancel out, and we end up with conservation of linear momentum for the whole system. And MAVAX1 plus MBVBX1 equals to MAVAX2 plus MBVBX2. So, conservation of momentum in X will give us the first relation. We need a second relation. We use the restitution coefficient. And as we mentioned, all velocities in the restitution coefficient are projected along the line of impact. Since the line of impact here is X, so I take components of velocity along X. So I end up with two equations, two unknowns. I can solve for my components along X. And along Y, since no impulses are acting in this direction, the velocity is conserved. So we find VAY2, VBY2. And now once we have the components of final velocities, we can easily determine their direction and magnitude. For the magnitude, we do radical Vx squared plus Vy squared. And for the direction, we do 10 minus 1. We can first determine the quadrant, and then we do 10 minus 1 Vy over Vx. Okay? In absolute value. So this is the chapter of angular momentum. You don't have, of linear momentum. You don't have the remaining slides. They are posted just for your own information. You don't have in this course angular momentum. Okay? So this is end of chapter 15. Any question on
Doctor,
this?
yes. In
Yes.
this exercise,
Yes.
نحن we consider إنه sigma إنه integral of f ts is equal to 0 لأنه there is no friction first
Yes.
and the, if
And
هلا نحن
the weights are non-impulsive.
yes, this was my question. How do we know if the weight is impulsive or not? You know, if there's no
Okay,
time.
look, always, أول شيء first, you need to know if it's a horizontal plane or vertical plane. Okay? هلا here, they didn't mention anything. They didn't mention if the collision is in a horizontal or vertical plane. And they didn't give you the time of collision. If they don't give you the time of collision, this means that it's really short. And if it's short enough, all normal forces as weight, normal reaction, etc., are considered to be non-impulsive because you do integral force dt and the time is really short and the force magnitude is normal and it's not a very large magnitude. So when you do integral w dt, it will be negligible since dt tends to 0. Okay? While
As long as the time is not mentioned,
as long as the time is not mentioned exactly, I can consider that normal forces that are independent of the collision force are non-impulsive.
Okay. Thank you.
Welcome. Other question? Okay. Let us open the review problems. Okay, let us consider the following example to show you different possibilities of oblique impact. So in the previous example of oblique impact, they gave us the line of impact. While in this problem here, we don't know the line of impact. So they said two smooth coins, A and B, each having the same mass, slide on a smooth surface with the motion shown. Determine the speed of each coin after collision if they move off along the dashed path. So hint here, they gave us a hint, but even if they don't give the hint, we should know what to do. Look, if they don't give you the line of impact, yani you don't know the if you want the direction along which the impulsive force is acting. And therefore, you cannot say here that velocities in x will be the same or velocities in y will be the same, because x or y are not the line of impact. So this means that velocities along x will change, and also velocities along y will change. But in this case, if you don't know the line of impact, they should give you additional information. If you remember in the previous example, we have 4 unknowns. Here, we just have 2 unknowns. You know why? Because they gave you all directions after collision. Yani you know the magnitudes of VA1, VB1, and you know all directions because they gave you angle alpha, beta, gamma, and you have the values of C and D. Okay, since you have all of these, then the directions are completely known. So what are your unknowns? What are your unknowns here? Your unknowns are the magnitude VA2 and VB2. Okay, so you have only 2 unknowns, and this is why you need only to write 2 equations. And here, what will be the 2 equations that you will write? If you take the system A plus B, you can apply conservation of linear momentum along x, and you can apply conservation of linear momentum along y. Okay, so this will be your 2 equations to apply conservation in x and y. So you take as a system A plus B. Okay, so when you take system A plus B, the impulsive force that is of unknown direction here, you don't know the direction of the impulsive force because you don't know where is your line of impact. But when you take system A plus B, you can say I can apply conservation of linear momentum for this system. And this conservation can be along any direction. You know why? Because conservation of linear momentum is actually a vectorial relation. Yani MA times vector VA at state 1 plus MB times vector VB at state 1 equals to MA times vector VA at state 2 plus MB times vector VB at state 2. And this vectorial equation can be decomposed into 2 relations, one in x and one in y. So here, this will be my 2 equations. So I can apply conservation of linear momentum in x and conservation of linear momentum in y. All I have to do is to project my velocities. Okay, so here, for example, for VA1 and VB1, you have everything. You have the magnitudes and you have the directions. So if you look at your figure, first, the projection of VA1 and x. Here, since you have the same mass for both, okay, the mass can be simplified because MA is equal to MB. You can cancel out the mass. And your vectorial equation will be VA1 plus VB1 equals VA2 plus VB2. So let us start with projection along x. Okay, so first, this is along, we need to project first along x direction. So if you look at VA1, it's a negative component, so minus VA1 magnitude, which is 0.5, times cosine of this angle. Okay. Here they didn't give you the angle directly, but they gave you this triangle. So this is, they told you this is C and this is D. Okay. So cosine of this angle, cosine, if I call this angle theta, cosine of theta is C over radical C square plus D square. Okay. So this is why when you project VA1, it's minus VA1 times C over radical C square plus D square. Now for VB1, it's also a negative projection. So minus VB1 magnitude. Since we have the angle given with Y, so when we project, we do sine gamma. So minus VB1 sine gamma, and gamma is given to be 30, we replace. So minus 0.8 sine 30 equals to, at the final state, what do we have? According to the figure, VA2 has a negative projection. And since they gave us the angle with Y, so to project on X, we do minus VA2 sine beta. While for VB2, we have the angle given alpha with X, 30 degrees. So we do minus VB2 cosine alpha, which is cosine 30. And this will give us the first equation in which we have two unknowns, magnitude of VA2 and magnitude of VB2. So we need another relation to close the system. The second relation will be application of conservation of linear momentum along Y. So we have VA1Y. If we take this relation, the equation is VA1Y plus VB1Y equals to VA2Y plus VB2Y. Okay. So here also, all you have to do is to do projections, and you get a second equation relating between VA2 and VB2 magnitude. Okay, because all directions are provided in the problem. Because here they should give you directions since you don't have any idea about the line of impact. So you can only write two equations. Okay. But when you know the line of impact, you can write four equations. Why? Because in the direction perpendicular to the line of impact, no change in velocity. So you end up with four equations, four unknowns. But here, since you don't know where is the line of impact, you can only write two equations, which correspond to projection of the linear momentum equation along two directions. Okay? Any question on this? I want to add a question now. Can you tell me, after calculating the final velocities, can we determine the direction of the line of impact? How can we find now the direction of the line of impact after calculating the final velocities? Who has an idea?
If we have the angle of the final velocity, we can do the projection.
No, you have the angle of the final velocity, but do you know where is the line of impact to project on it?
We have the final angle, so we can use
the final angles, you know them with X and Y. Okay? And you have angle of final velocities, but are your final velocities, we said we are in the case of an oblique impact. In case of oblique impact, velocities, all velocities will have a certain angle with the line of impact that is unknown here. We know the angles.
بنحط equal 0 يعني ال velocity cosine angle is equal to 0 we solve for the angle.
Okay, this is a procedure, but it's really complex. You have a much easier way. Look, what is the definition of the line of impact? مش هي is a line along which we have the impulse?
Yes.
So if I can find the impulse vector has two components. one in X, one in Y. So I have an impulse in X along I, and I have an impulse in Y along J. If I can calculate my impulse vector, I can say that this impulse vector is along the line of impact. So if I find the line, the impulse vector, the direction of this vector is the direction of the impulse line, is the direction of the impact line. Okay. طيب, how can I find Ix, Iy? What is the impulse vector? Is the impulse between A and B. How can I get this vector? Anna, when I asked you before to find the impulsive force, what did you do?
We applied the principle of impulse
MV1
and momentum,
Yes. So I take or A alone or B alone.
or B alone.
Yeah, exactly. So if I take A alone, for example, okay. Now I know initial and final velocity. If you look at the figure, okay, I have everything. I know VA1 magnitude and direction and the VA2 magnitude and direction. So let's say this is VA1 and this is VA2, and I know them completely. Okay. So I can say, let me apply the principle of impulse and momentum on A. I want to determine what is the impulse of B on A in X and in Y. Okay. So first, in X direction, what can I write? MA times VA1X plus the impulse of B on A along X. I don't know the direction. Let me consider that I don't know the direction of this impulse. I need to determine it from calculation. So I have IB on A along X equals to MA VAX at state 2. You have already calculated VA 2x. So we know VA 2x from, since we calculated VA2 magnitude and we know the angle we project along x. So we can find VA2x, okay? So now, the only unknown in this equation is IB on A in x direction. It's equal to MA times the change in velocity along x. So it's MA times VA2x minus VA1x. This will give us the impulse in x. If we write the principle of impulse and momentum in y, we obtain a similar relation, but instead of x, we put y. So we can say that the impulse of B on A along y is equal to MA times VA2y minus VA1y. Okay. And now once you solve for impulse in x and y, you get the vector. So you can find its direction. The direction theta of this vector, you can find it by doing tan minus 1 Iy over Ix. Okay. And theta will be the direction of the impulse vector, which is the same as the direction of your impulse impact line. Because the impulse vector is along the impact line. Okay. Question on this?
No.
Okay. So we are done for today. We'll continue with problems next time. Okay.
بس دكتور you said إنه in 2 weeks معقول يكون الإكزام.
They sent an email that probably will go back to campus next week. But no exams for the first week of on campus. So just after, yes, we can have the exam. The
اوكي
week
بيكون
just
عن chapters 12 13 أو 14 كمان.
آه، يعني خلص خلينا على 12 13. I don't want to add a load on you. And we'll have 14 15 for exam too, okay?
Okay, thank you, doctor.
Any question on this? Okay, يلا. See you next time. Bye bye.
Doctor,
Yes.
can I ask a question or
Yes, sure you can.
just
On which?
about when we have public impact?
Yes.
Why we said that VA1 is equal to VA2? No, which relation we did?
No, VA1 equals VA2 in
No,
Y.
and VBY, yes, in
Yeah.
my direction.
Okay. In case the line of impact is X, okay? If I tell you that the line of impact is X, so when the two particles will collide with each other, the impulsive force between them will be along the line of impact. So do you have any force between them in the perpendicular direction?
No.
No. Since in the perpendicular direction you don't have an impulsive force, the velocity will not change. Because look, if you look at this equation, what will change the velocity? The presence of an impulse. If you don't have an impulse in y direction, the velocity in y will remain the same. So if you know the line of impact, you can say that in the perpendicular direction, there is no impulsive force since you have smooth contact here, no friction, okay? And weights are non-impulsive forces. So along the perpendicular to line of impact, you don't have any impulse. And if you don't have an impulse, this means that the velocity along this direction will remain the same.
Okay, and we take each particle. We take a particle A, and we apply the principle.
Yeah, but please pay attention here. In this problem, you cannot say in y no change in velocity. In the problem we did
Yes,
before.
and line of impact هون غير.
Exactly.
Yes.
But here in this exercise, we don't know where the line of impact is. So we cannot say velocities in y will not change. Velocities in x will change and velocities in y will change. Only velocities will not change along the perpendicular to the line of impact. Okay?
Okay, deal, doctor.
Other questions?
دكتور بس for next week رح نبلش chapter جديد أو نكفي review problems.
We can continue with one session of problems and then we start with a new chapter.
Oh, thank you.
You will upload this recording now or?
Yes, I will upload it today.
Okay, thank you, doctor.
Okay, bye.